Hey everybody, now that we've learned to graph sine and cosine functions and do all the transformations, we don't want to leave the other trig functions out. That would just be not fair. So what I want to do today in this video is teach you how to graph a tangent curve. Okay, so we're going to graph the basic tangent curve, which is y equals tangent x. And again, because I know you have no knowledge of what a tangent curve looks like, we're going to start from scratch and do it by a t-table, plotting points. Once we figure out what a tangent curve looks like, then we're going to come up with the shortcut. All right? Is everybody ready? So in your notes, you have a pre-set up t-table. And I know I've picked out the angle measurements we're going to use. Now to graph tangent, if you look, I'm not going from 0 to 360. I'm using some positive angles and some negative angles. And there'll be a reason why in a minute when you see the curve. Okay. Well, we know we evaluate without a calculator, a trig function. We need our buddies. Unit circle, 3 special right triangles. I don't have to worry about the reference angle rules because, again, if you look here, I've only picked angles that we know. All right, that are on here, on our right triangles or on our unit circle. All right, so let's get started. Let's start with the easiest. Let's start with our quadrantal angles. So I'm going to start with 0 degrees. To look up the tangent of 0 degrees, I would go to my unit circle. So here's my unit circle. What is your definition of tangent from the beginning of the course? On the unit circle, it's y over x, correct? So y is 0, x is 1. What is 0 divided by 1, y'all? Very good. 0 divided by 1 is 0. We all agree? All right, our next quadrantal angle is 90 degrees. So let's look up the tangent of 90 degrees. So tangent again is y over x. That would be y is 1, x is 0. So guys, what is 1 divided by 0? Very good. There is no value of that, so we call that undefined. All right, we have another quadrantal angle on this list. We have negative 90 degrees. So going back to the basic concepts of this course, if I'm here, if my initial ray is on the positive x-axis and my terminal ray is at negative 90, I would rotate clockwise. So right here is negative 90 degrees. The definition of tangent is y over x. So that would be negative 1 divided by 0. What is the value of negative 1 divided by 0? Good. You cannot perform that operation. That's why we call that undefined. Everybody's with me? All right. Now we're going to look up the special right acute angles. Let's look up the tangent at 30 degrees. So to look up tangent, we're going to go to our 30-degree triangle. The definition of tangent is always y over x. So y is 1, x is square root of 3. We don't write 1 over square root of 3. We rationalize this expression, and we get square root of 3 over 3. Now we're going to look at the tangent of 45 degrees. So we go to our 45-degree angle. Tangent is y over x. That's 1 over 1, which we all know is 1. We're going to look at the tangent of 60 degrees. 60 degrees is y over x. That's square root of 3 over 1, which is just square root of 3. Because 30, 45, and 60 are all in what quadrant? The first. We know these trig function values have to be positive because all trig functions are positive in quadrant 1. Everybody's good? Now, if you look here, negative 30, negative 45, and negative 60, those angles would not be in quadrant 1 because from the beginning of the semester, if we were drawing them, here would be our initial ray on the positive x-axis, but to draw a negative angle, you would go clockwise. So negative 30, negative 45, and negative 60 would all fall in quadrant 4. Well, if tangent is in quadrant 4, is the value going to be positive or negative? Well, all students take calculus. The C means cosine is positive, so that means by definition all 3 of these values have to be negative. Now, technically speaking, we have to make reference angles. Because remember, reference angles are between 0 and positive 90. These are not between 0 and positive 90. So because they're in quadrant 4, we want to use the reference angle rule. So if you remember, in quadrant 4, the reference angle rule is 360 minus theta. But to use that rule, your angles have to be positive. So how do you make a negative angle positive? What's that word? What do you call angles that land in the same spot? Coterminal. How do you form coterminal angles? You add and subtract 360. So let's just take negative 60 degrees. If I take negative 60 degrees and I find its coterminal angle, if I add 360 to that, I get 300. Do you agree 300 degrees is still in quadrant 4? But now that that's in quadrant 4, I can use the reference angle rule. So 360 minus 300 would give you what? Oh, it would give me back to 60. So when I have these angles in quadrant 4, their reference angles are just going to be the positive value of them. Make sense? So when I want to look up the value in negative 60 degrees, I'm really looking up the value of 60 degrees. So I'm going to 60 degrees. Tangent is y over x. Square root of 3 over 1 is still square root of 3. When I'm looking up the tangent in negative 45 degrees, that's really looking up the tangent of 45. 45 degrees, tangent is y over x. 1 over 1 is 1. When I'm looking up the tangent of negative 30 degrees, that's really looking up the tangent of 30 degrees. So again, tangent is y over x. That's going to be 1 over square root of 3, which you rationalized a minute ago to be square root of 3 over 3. So there's our t-table filled in. Now, we know to graph, we have to set up our xy axis correctly. Can you put degrees on your x-axis? No, you cannot. Everything's got to be in what form? Radians. All right, so let's change our radians. 0 degrees is 0 radians. These are the guys, these angles are going to come up a lot, so by now you should have their radian measure memorized. But if you don't, just think, what does pi stand for as degrees? 180. So think, what would you divide 180 by to get these angle measurements? To get 30 degrees, you'd have to divide 180 by 6. So this is pi over 6. To get 45 degrees, you'd have to divide 180 by 4. So this is pi over 4. To get 60 degrees, you would divide 180 by 3. This is pi over 3. To get 90 degrees, you would divide 180 by 2. So this is pi over 2. Make sense? And then we'll put our negatives, radians here. Okay, so what I'm going to do is I'm going to set up my x-axis. This is 0 radians. Remember, we need to be consistent. First, let's look up here. Is everything here in an equal scale? Are we skipping the same amount? Well, let's go from here. From 90 to 60, that's 30. From 60 to 45, ooh, that's only 15. From 45 to 30, that's only 15. From 30 to 0, that's 30. So you can't just put every line one of these radian measure. Because you can't go, I'm going by 30s, then I'm going by 15s, then I'm going by 30s, then I'm going by 15s. So we're going to have to scale by 15s. So here's a line that means 15. I don't have 15 degrees. Here's a line for 30. I have that. After 30, if I add 15, I'll have 45. Got that. At 45, I'll add another 15. That gives me 60. Have that. 60, if I add another 45, that would be, if I add another 15, 16, 60 plus 15 is 75. I don't have 75, so I'm going to leave that blank. If I add another 15 to 75, I get 90. And then on the left side would be the same thing. This line would be negative 15 degrees, so this would be negative 30, then negative 45, then negative 60. I don't have negative 75, but I have negative 90. Everybody's good? All right. To graph the y values, you're right. You can't keep them in radical form. Let's convert them to decimals. Okay? We talked about this. Square root of 3 is roughly $1.70. So this is approximately negative $1.70. This is square root of 3 over 3. So $1.70 divided by 3 people. Okay? $1.70 divided by 3 people. Do you agree that's almost 60 cents? So this is approximately negative, and if you get your calculators out, which I will, if you want to be exact, I'll get my calculator out. Let me get my calculator. If you really want to know what the square root of 3 divided by 3 is exactly, it's decimal point 577350269. I don't need to know that approximately. It's, if you round it, it's about negative 6/10. All right? So this is, again, square root of 303 is approximately 6/10. Square root of 3 is approximately $1.70. So when I set up my y-axis, I can see my highest y value right now is $1.70. So I'm going to do 1, 2. So I'll do -1, -2. Everybody's good? Now watch. Even though there's 1, 2, 3, 4, 5, 6, 7, 8, 9 angles listed on this t-table, you only technically have 7 ordered pairs to plot, because a point needs an x value and a y value. You need numbers. Undefined is not a number. It means there's no value at all. So I'll hold off on that. But we could plot everything else. So at negative 60 degrees, we're going to be at negative 1 7/10. So negative 60 degrees, here's negative 1 7/10. Just estimating. Oh, if I only would get it in the right spot in this black. Negative 60 degrees, negative 1 7/10. At negative 45 degrees, I'm at negative 1. At negative 30 degrees, I'm at negative 6/10. Okay, so I'm somewhere between 0 and negative 1. At 0 degrees, I'm at 0. Okay. At 30 degrees, I'm at 6/10. So here's 30 degrees, halfway. At 45 degrees, I'm at 1. At 60 degrees, I'm at 1 7/10. Somewhere between 1 and 2. So those are my points plotted. Now, what do you do when you get out a y value of undefined? Okay, this is something you may or may not know. You have an x value, that's legit. You have negative 90 degrees and positive 90 degrees on your axis. But you have no y value, which means you can't plot a point. So what goes in these spots for negative 90 and positive 90 are vertical asymptotes. Now, you've all heard the word asymptotes before in college algebra. An asymptote is an invisible line. So we don't draw it solid, we draw it broken. It's a line a curve approaches but never can touch. Back in college algebra, when you were graphing hyperbolas, you had to draw in those imaginary lines that are asymptotes. For trig functions, the asymptotes go straight up and down. They're vertical lines. So at negative 90 degrees, because this is undefined, I'm going to draw a vertical asymptote. That means when I draw this tangent curve, I can get close to this line, but I cannot touch it. The same thing at positive 90 degrees. Okay? So first thing that's different with tangent curves is they're not like sine and cosine curves. Sine and cosine are continuous. They go on forever and ever. Once you put your pencil and start tracing it, it doesn't stop. Tangent curves are not continuous because they have a break in them. Now, to see the picture of the actual tangent curve, we're going to connect the dots. So here's our point. Let me just erase that. Here's our first point. So if we start connecting, remember it's a curve. It's curving, it gets all the way to the origin. And then it curves like this. So it's a curve, it's not a diagonal line. Now, it doesn't stop at these endpoints. What happens here is on the right side, this curve is going to follow this asymptote. So it's going to get close and follow it. It's going to go up. On the left side, the curve is going to get close to that asymptote and follow it, so it's going to go down. So that is a tangent curve. Okay? That's what a tangent curve looks like. Now to discuss some vocabulary we've already talked about. We've talked about the word amplitude. What does the word amplitude mean? It means height. Well, guys, what did I put on the end of my tangent curves? I drew arrows. So can you tell me the height of this curve is going to be 5 or the height of this curve is going to be 100? No, because the arrow indicates it's going to go up forever and ever. So the first thing you need to know about tangent curves is there's no amplitude. There is no height. It's a trick question. Okay? Because the height's going to extend indefinitely to positive infinity and to negative infinity. Okay? This is one complete tangent curve. Okay? From college algebra, you would say that this is increasing. If you start on the left and trace it, your hand always goes up. So a tangent curve is an increasing function. What I want you to notice that's different is the period. It does not take 360 degrees to graph a tangent curve. This is one complete tangent curve. And it started here at this asymptote, negative 90, and it went to this asymptote, positive 90. And between negative 90 and positive 90 is not 360 degrees, it's 180 degrees. So for tangent curves, the period is changed. The formula is 180 degrees divided by the frequency. So that's a big change. So totally different than sine and cosine. We have no amplitude, no height. The period is not out of 360. It's only out of 180. It only takes 180 degrees to draw a tangent curve. And yes, you must draw the asymptotes. It's not optional. On a graphing calculator, if you have a graphing calculator, the asymptotes look really bad because they look like they're connected to the curve, and they're not. Asymptotes mean a line you approach but you never touch. In real life, your asymptotes are the dotted white lines in the middle of your road that you're driving. Your tire is supposed to get close to them but not touch them. So when you graph, the curve should never touch your asymptote. Okay, so let's talk. Our goal is going to be in the next video, how can we graph this quicker? Do we really need to set up the t-table, plot all 7 of these points? No. So let's look closely. To graph a tangent curve, what are we going to need to know? Well, the first and most important thing is we're going to need to have the 2 asymptotes always drawn. So when you graph me a tangent curve by hand, the first thing I'm looking is for the 2 asymptotes because the tangent curve is going to be in the middle of them. And you need to memorize this is your parent graph for tangent, which means with a tangent curve, the first asymptote starts at negative 90 and always goes to positive 90. Because later on we're going to be doing some shifting. Okay? So a parent, first thing you need to know about the tangent curve is you always put in the 2 asymptotes. And they're the same distance apart. They're the same distance apart from the point in the middle. Out of these 7 points, who's the point in the middle? It's right here, the origin. So to graph a tangent curve quickly, we don't need to know all 7 of these points. We just need to know the point in the middle and that it's the same distance from the 2 asymptotes. So what you need to go home and memorize is real simple. I'm going to erase this. You need to memorize, if I say we're going to graph y equals tangent x, which is the parent, the basic, you need to know the first asymptote goes at negative 90. The second asymptote goes at positive 90. And the point goes directly in the middle. From here to here is 180 degrees. Halfway would be here. And the point goes there at the origin. And then the curve goes like this. It starts down here. It follows the asymptote. It curves. And then it curves up. That's what you need to memorize about graphing a tangent curve. Okay, in the next video, we're going to do some transformations with this. I'll catch you then.